Hi there, grade 8s, and welcome to WorksheetCloud Maths. I hope you are well today and you are looking forward to today's lesson. If this is the first time that you are joining us, a very big welcome to you, and I hope you enjoy this lesson so much that you continue to watch our lessons. So let's get going. Today we're going to carry on with measurement. This is the 5th lesson in this series, so if this is the first time joining you, you can always go back and watch lesson 1, 2, 3, and 4. Otherwise, this is a standalone lesson. You can just watch this lesson, and it is going to be on circles and the perimeter of circles. So let's see. Okay, so just to recap from grade 7, a circle is a closed curve such that all the points on this curve are the same distance from a fixed point called the center of the circle. So any point on the circumference of the circle will be the same distance from the center. Okay, naught is the center of the circle, or O, we can call it O, is the center of the circle. And a line segment drawn from the center of the circle to any point on the circle is called a radius. And the plural of that is radii. So from the center of the circle going out to the circumference or to the outside of the circle is called a radius. Any straight line segment with its endpoints on the circle and passing through the center of the circle is called a diameter of the circle. And remember, 2 radii gives you a diameter because the radius goes from the center to the outside of the circle, whereas the diameter goes from the one side to the other side through the center of the circle. Okay, so if the length of the radius is r and the length of the diameter is d, then d is equal to 2r, as I said just now, because d is going from the one side to the center point, which is a radius, and then from the center point to the other side of the circle, and so 2r gives you d. 2 radii is 1 diameter. Okay, and the perimeter of a circle is called the circumference, as I've been mentioning throughout this, but you all knew that because this was just a recap from grade 7. So, okay, there's the circle, and we are going to look at the center point of the circle, labeled O, sorry, getting a bit tongue-tied there, and that would be a radius, okay, from the center point to the outside of the circle. And then if you have a look, that's also through the center of the circle, but it goes from one side right through the center to the other side, and that is the diameter. And then all the way around the circle, so that outside, this part of the circle, is the circumference. So in another shape, we would call it the perimeter, but for a circle, we call it the circumference. Right, so let's experiment. You will need 3 different cylindrical cans of different sizes. So guys, I would urge you to go and get 3 cylindrical cans. You can pause the video while you go and get that, and possibly a piece of string and a tape measure or a ruler would be great. And then let's see what we're going to do. So pause the video, go and get all the stuff you need, and then come back and we can do it together, or you can see what I've done with the cylindrical cans that I selected. So the first one was a tin of tomato soup. The next one was a tin of tomato paste, and the last one was a coffee tin, okay, a tin of coffee. Okay, so what we're going to do is we're going to carefully measure the diameter of each tin. So you're going to go across from the one side to the other side, and you can use your tape measure or you can use your ruler. So you'll do that with each tin, starting with your first tin measuring across, the second one measuring across, and the third one measuring across. Try very carefully to make sure that you go through the center of the circle, because this is obviously a circle, so make sure that you cross the middle point. All right. After you've done that, you need to carefully measure its circumference. Here, you can use a piece of string and put it right around the circumference of that circle, and then take the piece of string. You can mark on the piece of string, take it, and then measure it on a ruler, or you can actually just go around your tin with a tape measure. Try to be as accurate as possible. Okay, so now we're going to put this on a table. And here we have a table. Tin 1 we got a diameter, sorry, we need to convert when we do this part to 4 decimal places. But let's first start with the diameter. Remember, that was taking your ruler and measuring across the top of each tin. So your first one, my tomato soup, was 7,6 centimeters. Okay, whichever tin you got, just go with me with the working, and you would have measured accurately across that, and that's what you put in that first space. The next space was using your piece of string and going right around the outside of the tin, and then measuring it either against your tape measure or your ruler. So it's going around my tomato soup can, I got 23,9 centimeters. Now what I do is I take my circumference and I divide it by the diameter, and I ended up with 3,1447 centimeters. Remember, it said correct to 4 decimal places. This calculation you could just do on your calculator, so don't try and work it out manually because you're working with lots of decimals here. It's so much easier just to work with your calculator. Okay, so you should have got something. It doesn't matter what your measurements are here, you should have got something in this range. Right, let's look at the next one. My tomato paste can, the diameter, so across the top of the can, was 5,7 centimeters. My circumference, measuring around the can with my piece of string, I got 17,9 centimeters. I then take my circumference of 17,9 centimeters and I divide it by 5,7 centimeters, and have a look. I get 3,1404 centimeters because that's to the correct 4th decimal place. Now have a look. It's very, very similar. Let's see what happens with the coffee can or the coffee tin, because that's so much bigger. Okay, so the diameter was 13,1 centimeters. The circumference is 41,2 centimeters. I take the circumference and I divide it by the diameter, and let's see what we get. 3,1450 centimeters. Okay, all very, very similar. I wonder if you got very similar answers to that. Remember, these need to be very carefully measured so that you are accurate. Okay, so what can we see? Well, there's the table again, all filled in. And if you look at your table, it should look sort of similar, especially this part. And if you work very carefully and accurately, your answers should be between 3,10 and 3,20. And in fact, they should be as close to 3,14 as possible. Okay, so it doesn't matter how small or large a circle may be, the ratio of the circumference over denominator always turns out to be pretty much the same, which then becomes our constant. And the constant is shown by that Greek letter, and we call it pi. So you actually pronounce it as pi, P-I. Okay. Pi is needed to calculate the circumference of the area and the area of a circle. But for now, we're just going to be looking at the circumference. So correct to 9 decimal places. If you worked it out on your calculator, pi is equal to 3,141592,654. But we are actually only going to use it to the 2nd decimal place. So every time we use pi, we're going to refer to it as 3,14. Right, if the circumference of a circle is C, the diameter is D, and the radius is R, then C over D, okay, circumference over diameter, is equal to pi. So C is equal to D pi, because remember, using algebraic form, we're going to multiply the d out to get rid of the denominator, which means that we have to multiply this side by d. So c is equal to d times pi. And we know that d is 2r. So c is equal to 2r pi, but we say 2 pi r. It's just easier to say it. It works out exactly the same because you're going to go 2 times pi times whatever the radius is. Okay, so let's put that into practice. Here's a circle, there's the center point with a radius drawn in, and that radius is 5 centimeters. So if we wanted to work out the circumference, we now know what the formula is for circumference. It is 2 pi r. And it says here, calculate the circumference of this circle correct to 1 decimal place. Well, we know what pi is. It's 3,14. We've already established that by measuring our own tins. Okay, so we're going to go 2 times 3,14 times our radius, which is 5. So 2 times 3,14 is going to give me 6,28. I'm going to multiply that by 5, and we're going to get a radius of 31,4 centimeters. Not a radius, sorry, a circumference. Remember, the circumference is like the perimeter of a circle, but we don't call it a perimeter, we call it a circumference. Okay, so that's quite easy. All you need to do is you need to plug into your formula, substitute in, and you will get your calculations, and you work it out on the calculator. You could always do it in one step. It's not a problem, and you should get 31,4 centimeters when the radius is 5 centimeters. Okay, so it's your turn. Here's a circle. There's the center point. There's the radius, and the radius is 2,5 centimeters. And I would like you to work out the circumference of this circle. So put your video on pause. You work it out on a piece of paper, and when you come back, we can go over it and see if you were correct. Right, let's see how you did. Okay, so you had to work out the circumference of the circle correct to 1 decimal place, and let's see how you did here. So remember our formula, circumference is equal to 2 pi r. So 2 times 3,14 times 2,5, because our 2,5 is given to us, but the constant is pi, and that's 3,14. Right, multiply it out. You're going to get 6,28 times 2,5 centimeters. Remember the first calculation, there's no units of measurements, only in the second part of the calculation that there is, because then we're using the radius. 6,28 times 2,5 should have given you 15,75 centimeters. I'm sure you all got that, because I'm sure you are used to working with circumference, because I'm sure you did do some of this in grade 7. Right, so it should be easy as pie. Remember, if you've got any questions, to please send an email to grade8@worksheetcloud.com if you're not understanding something, or you can just go back and watch from the beginning of the video, and then hopefully that will clear it up for you. Okay, right, can you complete this table? Here's a table with measurements put in for you, and now you have to figure out what the missing measurements are. So working from the radius to the diameter, that's pretty simple, because we know that all we do is double it. So the diameter of that first circle would be 8 centimeters. But to work out the circumference, we would have to probably show our working. So our working would be circumference is equal to 2 pi r. Remember pi being our constant at 3,14. So it would be 2 times 3,14 times 4, because remember we're going to use the radius. So there is our first line of working, 2 times 3,14 times 4 centimeters. 2 times 3,14 we know is 6,28 times 4, and that's going to give me 25,12 centimeters. Right, let's have a look at number 2. Okay, number 2, we were given the diameter of 12. We now need to work back and find the radius. So now we're not going to double it, we're going to halve it. So that would give me, there's our answer for the first line, that would give me 6 centimeters. Now we need to work out our circumference for that circle. So we know that circumference is equal to 2 pi r. We're going to substitute in. We know that pi is 3,14, so it's going to be 2 times 3,14 times our 6 centimeters for our radius. And we're going to multiply that out. We're going to get 6,28 times 6 centimeters, and that is going to give me 37,68 centimeters, and we can pop that into the table. Right, the third line of our table, we are given our diameter as being 100 millimeters. So again, we are going to halve that, and we are going to end up with a radius of 50 millimeters, which we can now work with to find the circumference. Once again, our circumference is equal to 2 pi r, 2 times 3,14 times 50 millimeters this time. And we're going to go 2 times 3,14 is going to give me 6,28 times by our 50 millimeters, and that's going to give me 314 millimeters. So we're going to pop that back into our table, and our table is now complete. Okay, just have another quick look. Remember, radius doubled gives me diameter. Then we've got to put our radius into the formula to work out the circumference. So just check that you got each one correct. If not, you can always go back and try and work out everything again. Okay, let's go on. Let's start applying your knowledge. All right, here is a circle. Well, it's actually a semicircle. And what do we have to do? Well, first of all, we are given that our sides here are 3 centimeters. We are then given that the middle part is 6 centimeters. Okay, so we've got an outer circle almost and an inner circle. So what do we have to do? We have to calculate the perimeter of the shaded area. Why don't you try and do this on your own? So pause the video, and when you come back, we can then go over it together. I'm sure you'll be able to figure out exactly what to do. Right, let's see. So we have to work out the area of the perimeter, of the shaded area, which means we have to go around there, we have to go along there and around the back and back along there. So here we've got perimeter is equal to half the perimeter of the outer circle plus half the perimeter of the inner circle, which is actually half the circumference of the outer circle, plus half the circumference of the inner circle, plus 3 plus 3. So actually what we're doing is we're going to go the outer circle. Okay, that's half of the outer circle. It is a semicircle. So we've got to work out the perimeter or the circumference and then divide it by 2. The same with the inner circle, this one. And then we've got to add on that and add on that so that we get the whole perimeter. Okay, because we've got to work out the perimeter of the shaded area. So if we do that, it's going to be a half times 2 pi r plus a half times 2 pi r plus 6 centimeters. This one refers to the outside. This one here refers to the inside. And then our 3 and our 3 gives me 6. So it's that 3 and that 3. Because remember, we're working with perimeter. Okay, so we're first of all going to go 2 times 3,14 times half of 6. Let me just double check this quickly. Sorry about that, guys, the whole lot. Okay, so we've got half the perimeter of the outer circle, because it's a semicircle, plus half the perimeter of the inner circle, because that's also a semicircle, plus the 3 and plus the 3 on the other side, here and here. Okay, so if we add the 3 together, we're going to get 6, and it's half 2 pi r plus half 2 pi r. So the one is the outer side and the other one is the inner side. Okay, so that would give me 2 times 3,14, because that's pi, plus the radius actually would be, I've also left something out here, I think. The radius would be 6 plus 3, which is actually half of that. So let me just fix that again. Sorry, guys. But now we can carry on, because I think it's now fixed for the last time. Okay, so the 6 centimeters here being the radius of the bigger circle, because it would be 6 plus 3, which would be the diameter. That would give us 12. So half the diameter is the radius, which is then 6, which is here. Okay, plus half times 2 times 3, because that's pi, times 3 centimeters, because now we're working with the inner circle. So half of 6 would give me 3. So the 6 would be the diameter of the inner circle, and 3 then the radius, okay? Plus this 3 and this 3 for the other part of the perimeter of the shaded area. So we'll first go 2 times 3,14. So we end up with then half times 6,28 times 6 and half 6,28 times 3, right? Then let's multiply what's inside the brackets. We end up with half, because 6,28 times 6 is 37,68 centimeters. 6,28 times 3 is 18,84 centimeters. So if we were working out the circumference of the whole of the bigger circle, it would be 37,68 centimeters, and the whole of the inner circle would be 18,84. But remember, we're only working with half of those circles, so it's half of their circumferences. And then we're adding on the extra little bit for the perimeter of the whole shaded area. So half of 37,68 centimeters and half of 18,84 centimeters will give me 18,84 centimeters plus 9,42 centimeters plus 6 centimeters. So this is half of the circumference of the outer circle, and that's half of the circumference of the inner circle. Add on the 6 centimeters from the 3 and the 3. If we add that all together, we end up with a total perimeter of the shaded area as 34.26 centimeters. Right, quite a lot of working out there, but you just need to reason it out and see exactly what you need to do and fill in your formula accordingly, and then plug into your formula, so substitute in, and then just work it out using your calculator. Okay, guys, that's all there is for today. I encourage you to do the activity that is joined to this lesson, and check it against the memo that's also attached, and see if you can work out perimeter or circumferences of varying circles, or circles that are part of a shape, as in this one here. When you first look at it, you don't necessarily see the two circles, because it actually looks like an archway, sort of. But actually the archway is made up of two circles, so you can actually quite easily work out the perimeter of the shaded area. Thank you so much for watching today's lesson, guys, and I hope you enjoyed it. Please again, don't forget to email any queries or concerns that you have to grade 8 at WorksheetCloud.com, or you can watch the lesson from the beginning, revise everything, and then go and do the activity that is attached to the lesson. So thank you so much, and I hope to see you next time. Keep well, and bye-bye for now.